What we first reviewed in Chapter 1 was solving equations with one variable. So if we want to solve an equation like number 1, the easiest thing to do is to get rid of the fractions. And in order to get rid of the fractions, you want to multiply each term by the common denominator, or the lowest common multiple of the denominators. So if we look at 4, 8, and 2, the lowest common multiple is 8. So I'm going to multiply each term by 8. And that will give me 2 plus 3x equals 4. And so now to solve, I just need to subtract 2 to the other side. And my final answer is x equals 2/3. For part B, we first want to distribute the negatives. So we have 6 minus 1 plus 2x equals negative 3 minus 6x minus 10. Now we want to combine like terms. So we have 5 plus 2x equals negative 13 minus 6x. And I'm going to add 6x to the other side and get 8x, I still have plus 5, equals negative 13. Then we subtract 5 from each side. So I have 8x equals negative 18. And when I divide by 8, I'm going to have negative 18 over 8. And I want to reduce that fraction as much as possible. So I'm going to have negative 9 halves. For part C, I'm going to first distribute the 2. So I have 8x plus 10. And then I'm going to distribute the 1/2 to on the other side. So I have 6x plus 10 plus 2x, which gives me 8x plus 10 equals 8x plus 10. If I subtract the 8x, I'm just going to get 10 equals 10, which is the same as 0 equals 0. And whenever we have this situation, all real solutions work for x. So we have all real solutions. For part D, I'm going to distribute the 3/4. So the 4 will cancel with the 16 to make it a 4, so I'll have 12x. Minus the 4 will cancel with the 2, so that gives me 3/2. Plus 4 equals 12x plus 6. I'm going to turn the 4 into 8 over 2, so I have common denominators. So now I have 12x plus 5/2 equals 12x plus 6. If I subtract 12x from both sides, I have 5/2 equals 6. And since that is not a true statement, we know that no solution will work for x. So no solution is the answer. For number 2, we want to find the slope of the line that passes through the points 0, 3, and 4, 8. So I'm going to use the formula. Slope equals y2 minus y1 over x2 minus x1. And my y2 is 8, my y1 is 3, my x2 is 4, and my x1 is 0. So that gives me 5/4. So the slope is 5/4. The slopes of parallel lines are the same, or we can write equal. And the slopes of perpendicular lines are opposite reciprocals. In order to graph number 4, I first want to isolate y, so I'm going to add y to the other side. And then I'm going to subtract 3x. So I have y equals negative 3x plus 1. Now I'm ready to graph because I know the slope of my line, which is negative 3, and the y-intercept, which is positive 1. So to graph my line, I'm going to first start with my y-intercept at positive 1, and then I'm going to move up 3 and over 1 from that point. To get another point on the line, I'm going to go down 3 and over 1. And that gives me enough points to draw my line. For number 5, we already have our line in slope-intercept form. So I'm going to put my y-intercept on at 4. And then for my slope, I'm going to move up 2 and over 5. And then I'm going to move down 2 and over 5 the other direction. And then I have enough points to graph my line. For number 6, 3x equals 18, we have to do a little bit of work before we graph. So first I'm going to just divide both sides by 3 to get x equals 6. So now I'm ready to graph this line. And since I have an equation that's x equals, I know that I have a vertical line that goes through 6 on the x-axis. For number 7, we also need to do a little bit of work before we graph. So I'm going to add the 2 to the other side. So I have y equals 2. And now I know that since I have a y equals equation, I have a horizontal line through 2 on the y-axis. For number 8, we can see that we have our equation in standard form. And whenever our equation is in standard form, it's easy to graph the x and the y-intercepts. To find the x-intercept, I'm going to plug in 0 for y, which just gives me 3x equals 12. So I know that I will have an x-intercept at x equals 4. So I'm going to put that on my graph on the x-axis. To find the y-intercept, I'm going to plug a 0 in for x, which gives me that 4y equals 12. So I'll have a y-intercept at y equals 3. So I'll put a point at 3 on the y-axis. Now I can just connect my 2 points, and I have a graph of my line. On the next page, we want to write the 3 forms of the line of a linear equation. So the first form we have is standard form, and that is ax plus by equals c. And we want to remember that a, b, and c are integers. So we can't have any fractions for a, b, and c. If we do end up with fractions, we just need to multiply by the lowest common multiple of the denominator and get rid of the fractions. The next form we have is slope-intercept form, which is y equals mx plus b. And then our third form for a linear equation is point-slope form, and that is y minus y1 equals m, which is the slope, times x minus x1, and x1 and y1 is our point that the line goes through. So for number 10, we want to write the equation of the line given the following characteristics in slope-intercept form. So since we know that the line has a slope of negative 4 and a y-intercept of 3, we can just use y equals mx plus b, and we can plug in a negative 4 in for our slope, and the y-intercept is 3. So our equation of our line is y equals negative 4x plus 3. For number 11, we have a slope of negative 3, and our line passes through the point 5, 4. So since we're given a point and a slope that the line goes through, we're going to use point-slope form, which is y minus y1 equals m times x minus x1. So for my y1, I'm going to plug in a 4. I'm going to plug in negative 3 in for my m, and I'm going to plug in a 5 for my x1. Now, since the question asked us to specifically put this into slope-intercept form, I'm going to distribute the negative 3 and then add the 4 to the other side. So my answer will be y equals negative 3x plus 19. For number 12, we want to write the equation of the line in standard form. And we are given that our line is perpendicular to the line y equals negative 4x plus 1, and it passes through the point negative 2 comma 3. So since the line that we want to write the equation for is perpendicular, we first want to find the perpendicular slope. And since we know that our slope is negative 4, the perpendicular slope is going to be the opposite reciprocal. So our perpendicular slope is going to be a positive 1/4. Now that we know that, we can use our point that we're given, that our line goes through, and write our equation into point-slope form. So we're going to have y minus 3 equals 1/4 times x plus 2, since we have a negative 2. So now we need to take our equation in point-slope form and transform it into standard form. So we want to remember that standard form, all of the coefficients and the constant are integers. So we don't want any fractions in standard form. And I see that my slope is already a fraction. So I am going to multiply each side of my equation by 4 to get rid of the fraction. So that's going to give me 4y minus 12. The 4 and the 1/4 will just become a 1, so I'm just left with x plus 2. And we only need to multiply the 4 by the 1/4 because it gets distributed anyways. So now we need to get the x and the y on the same side. So I'm going to subtract x to the other side. So I have negative x plus 4y minus 12 equals 2. I'm going to add the 12 to the other side to get negative x plus 4y equals 14. Usually we see that in standard form that the first term is positive. So if you have the answer x minus 4y equals negative 14, that would work as well. So both of these answers are correct and acceptable. For number 13, we want to write the equation of the line in standard form again, and this time we just know that it passes through the point negative 2, 5 and 4, negative 7. So the first thing we want to do is find the slope of this line. So we're going to use y2, negative 7, minus y1, which is 5, over x2, which is 4, minus a negative 2, which will become a positive. So we end up with negative 12 over 6, so we know our slope is negative 2. Now we're going to use the slope that we found and one of the points and first write our equation in point-slope form. And I'm just going to use the first point. So now we have y minus 5 equals negative 2 times x plus 2. And we want to get our equation into standard form, so I'm going to distribute the negative 2. So I have y minus 5 equals negative 2x minus 4. And then I'm going to add the 2x to the other side. So 2x plus y minus 5 equals negative 4. And then I'm going to add the 5 to the other side. So I have 2x plus y equals 1. And that will be my final answer in standard form. Next, we want to graph the equation y equals negative 2/3 times the absolute value of x plus 1 plus 5. So the first thing I'm going to identify is the vertex of the absolute value graph. Now we can find the vertex by identifying the h and the k in our equation. So the h is a negative 1 because remember it's opposite of what is inside with the x, and a positive 5. So I'm going to label my vertex as negative 1, comma 5, and I'm going to plot that on my graph. So Negative 1 comma 5 right there. Okay? Now I'm going to use the slope, or the a value, of my absolute value graph to plot the rest of my points. So since my a value is negative 2/3, I'm going to go down 2 and over 3 in both directions to start forming the V shape of this absolute value graph. And I'm just going to go down down 2 and over 3 one more time. And then that is our absolute value graph. So the question is, for number 15, will the absolute value graph with a small absolute value of a value be wide or narrow? So if I have a small value in between 0 and 1, like negative 2/3, will I have a wide graph or will I have a narrow graph? And our answer is a wide graph. When we have a fraction for a slope, we get a shallower line or a wider graph for the absolute value. If we had an a value of something like 3, we would have a very narrow absolute value graph. For number 16, we're asked to describe the transformations of y equals negative 2/3 times the absolute value of x plus 1 plus 5 from the parent graph y equals the absolute value of x. So what this is asking for is just the differences between the most basic graph of y equals the absolute value of x and the graph that we just graphed. So really quick, let's graph y equals the absolute value of x. And we know that it's a V with its vertex on the origin. I know I didn't graph that too well. And it has a slope of 1. So how is the graph that we just graphed different? Well, our vertex definitely moved. And our vertex moved 1 unit horizontally, and it moved to the left. And it also moved vertically 5 units, and it moved up. Because our parent graph is facing up and our new graph is facing down, our graph was reflected over the x-axis. And finally, our new graph is more wide than our parent graph. So what happened was we had a vertical shrink of 2/3. Problem 17 asks, a system of linear equations with 2 parallel lines has how many solutions? So if we think about what a solution is to a system of linear equations, it is the point of intersection between 2 lines. So if we have 2 parallel lines, do they ever intersect? The answer is no. So if we have a system of linear equations and it's 2 parallel lines, it will always have no solution because parallel lines never intersect. If we have a linear system and we have a line, and then we find out that the second equation is the same exact line, how many points of intersection do those 2 lines have if they're lying right on top of each other? And the answer to that is infinitely many solutions. So infinite solutions. So if one line lies right on top of the other line, it intersects everywhere. So we have infinite solutions. For number 19, we want to graph the system of linear equations to find the point of intersection. So first I'm going to graph 6x minus 3y equals 15. And I'm going to first get that into slope-intercept form. So first, I'm going to subtract the 6x to the other side, and then divide by a negative 3. So I get y equals 2x minus 5. So I'm going to put my y-intercept down at negative 5, and then carefully go up 2 and over 1 so I don't miss my point of intersection. And try to draw my line as carefully as possible. Next, I'm going to graph my second line. And to do that, I'm also going to get that into slope-intercept form. So I'm just going to add the 2 to the other side. And I also get y equals 2x minus 5. So I'm just graphing the same exact line. And if I graph the same exact line, we know that we have infinite solutions. For number 20, we want to solve the system of equations using elimination. So if we take a look at 2x plus 5y equals 10 and negative 3x plus y equals 36, we want to decide whether or not we want to eliminate the x value or the y value first. So in this case, both x and y look a little difficult to eliminate, but I'm going to go ahead and try to eliminate the x value since it's slightly smaller numbers. So since 2 and 3 both go into 6, I want the x values to become a 6. So I'm going to multiply the top equation by 3 to get 6x plus 15y equals 30. And I'm going to multiply the bottom equation by a 2. So I have negative 6 plus 2y equals 72. Now the x and the x's eliminate, so I'm left with 17y equals 102. Hopefully 17 goes into 102. So divide both sides by 17. And it does. We get y equals 6. So now that we know that y equals 6, we can plug that back in to solve for x. So I'm going to plug that into the second equation. So I have negative 3x plus, fill in the 6 for y, equals 36. So negative 3x equals 30. So x is going to equal negative 10. And I want to write the final answer as a coordinate. So my final answer is negative 10, comma 6. We want to make sure we go x, comma y. For the last problem, we want to solve using substitution. So we want to take a variable that looks easiest to isolate and move everybody over to the other side. So to me, it looks like that the x in the second equation is pretty easy to isolate. So I am going to subtract 3y to the other side. Now I'm ready to substitute negative 3y plus 8 into the first equation. So the 2 is going to stay, and in for the x is going to go the negative 3y plus 8, and then I still have the minus y equals 9. And now I'm going to solve for y. So I'm going to have negative 6y plus 16 minus y equals 9. So negative 7y plus 16 equals 9. So negative 7y equals negative 7. So y equals 1. And now I'm ready to solve for x. So I'm going to take the 1 and plug it back in. And I'm going to substitute it into the first equation. So I have 2x minus 1 equals 9. So 2x will equal 10. So x equals 5. So again, I want to write my final answer as a coordinate. So my final answer is 5, 1. We can check to make sure that these are the solutions by plugging them back in to make sure that they work for the equation. So if I wanted to check 5, 1, I can plug that into the first equation. 2 times 5 is 10 minus 1 is 9, so that works. And 5 plus 3 times 1 is 8, so that works. Let's check number 20, just to make sure we got the right answer. So if I plug a negative 10 in for the x in the first equation, I get negative 20. If I plug a 6 in, I get 30. So negative 20 plus 30 is 10, so that works. And if I plug a negative 10 in for the second equation, I get a positive 30. Plus a 6 is 36, so that works as well. So checking these solutions is always a good idea to make sure that you got the right answer.